Hello class, hope you've been doing good. Meeting after almost a week time. So what we do today is we take a situation in which there is a situation in which there is given to us a conductor with resistivities rho1 and rho2. Certain length, if you want, you may assign to them L1 and L2. Area of cross section to begin, we assume same. We are applying a potential difference across the ends. And to our surprise, what we asked over here is, will there be any charge developed at the junction? So what will be charge in this little box? If there is any charge to be developed, what will be charge developed in the little box? That is one question. So how to make an approach to this question? First and foremost, we are known to KCL. It comes as a surprise that there will be any accumulation of charge. Charge conservation is what we have been harping on. And we have advocated the case of conservation of charge with KCL, Kirchhoff's current law. Now here, slight departure. That departure is predicated on rho1, rho2. They have gotten you the value of rho1, rho2. Rho1, rho2 isn't same. So what should we do? How should we begin with it? We should begin with what may known to us. Whenever you are to begin to make a journey, what being known to us plays a very important role. So everything known to you play a very important role. What we write is E dot ds known to us is equal to Q by epsilon. We take help of this. We write it as E1 the field over here, E2 the field over here. Just a moment, let me check what is the frequency here. Oh, better. So E1 field over here, E2 will be the field over here. What then we can say is E1 minus E2. See over here, you get to know that E can be marked as, this goes down, charge per unit length. If we mark it E and ds in the same direction, then E can be marked as sigma by epsilon naught. Or if you want to take only the magnitude E in the same direction, we can remove the bar over it. We then get to see that sigma is equal to epsilon naught. So E1 is entering, E2 is coming out, they are in the same direction. We can mark it as E1 minus E2 delta S. Delta S is the area, surface area of the pillbox. Should be equal to, from this formula, what should be written equal to for yourself, right? For this. And then you get to know that E1 minus Es delta S, if we are multiplying, this is charge per multiple, right? So Q we take down, we get it as a sigma from here. We get it as, then we take it and remove it. E1 minus E2. So what do we get from here is sigma by epsilon naught. I take epsilon on this side, then by sigma. This is a charge, and all the charges to be accumulated. The amount of charge which we are being fit is accumulated over here. Then we get to see that charge will be marked as sigma naught or sigma as I have coordinate area. Epsilon naught E1 minus E2. That is what we get to see. Now E1, E2 we are aware of V is equal to IR, Stockholm known to us, and this can be written as rho L by A. We have quite answered this as well. So V by L is what to us is equal to I by A into rho. Discounting on the vector term, J rho is equals point form. This is the point form. It's long, right? We can write it as J is equal to sigma E, where sigma is 1 by rho. So rho is a distributed, sigma will be reciprocal, which makes it conductive. Be careful of the sigma and the sigma. Okay. What next? We can now mark here J to one side, J to the other side. You want it to know to us. So this formula I will be making good of. And this formula is what I am to apply over here. Also known to us is V is equal to E1 d1 plus E2 d2. E1 d1 plus E2 d2 mark. Can we take current same? If current I is flowing through this, then I will flow through this as well. From here, J by sigma, J by sigma or J by sigma. If I'm taking this down, see, you can write J as the one that I have written, or you can write it as E by rho. Right? I think it's lagging now. So quick on this. E by rho gets us E1 by rho 1 is equal to E2 by rho 2. We can place over here, substitute one by the other. We get E2. Once we get E2, we can place over here and get rho sigma. So as it is lagging, I will see to you on the other side. Thank you.